Good day everyone, welcome to my channel. In this video I'm going to show you how you can prove by mathematical induction. Mathematical induction is a method of proving statements for all rational numbers by verifying two steps. The first step we have the base case, which is n equals to 1. In this step, we need to show that the statement is true for the first value. The next step we have is the inductive step. We have the inductive step. In this step, we assume that the statement is true for n is equals to k. Then we prove it for n equals to k plus 1. We assume that n is equals to k, and also we prove it for n equals to k plus 1. So let's quickly see an example. Now let's prove by induction that 1 plus 2 plus 3 plus all the way to n is equals to n open bracket n plus 1 over 2. You can observe that this series is identical to an AP series, which is an arithmetic progression series. If you are to find the sum of this series, we say Sn equals to n over 2 open bracket 2a plus n minus 1 multiplied by d, where a is the first term, d is the common difference, and n is term. So if we are to find the sum Sn, say n over 2, because the nth term is n at the left hand side, so we have 2a, whereas we have a as 1 plus n minus 1 multiplied by d. The common difference in this series is 1, because if we are to find the difference between these three terms, the second term minus the first term, which is 2 minus 1, we have 1. Then the third term minus the second term, which is 3 minus 2, we have 1. So d is equals to 1. Then Sn will be equals to n over 2. 2 multiplied by 1, we have 2, plus n minus 1 multiplied by 1, we have n minus 1. Then this gives n over 2. 2 minus 1 is 1. Then we have n. So n plus 1, which is what we have at the right hand side. But how do we prove it by mathematical induction? In the beginning, I highlighted two steps, the base case and the inductive step. So let's do the base case. The base case said we have to set n equals to 1. So don't forget, we need to show that the statement is true for the first value. So if n is equals to 1, then the right hand side will be the right hand side of this question will be 1. Because n is 1, we have to substitute 1 for n. So anywhere we see n, we are going to write 1. So we have 1 plus 1 over 2. So 1 multiplied by 2 over 2, this gives 1. So we have 1 at the left hand side, we have 1 here, and we have 1 here, which is true for the first term. We can also set n equals to 2. Then if n is equals to 2, the right hand side of the question becomes 2 multiplied by 2 plus 1 over 2, which is 2 multiplied by 3 over 2, then 2 cancel 2, we have 3. Then don't forget, at the left hand side we have 1 plus 2. Because n is equals to 2, we are going to take the first two values at the left hand side. So we have 1 plus 2 is equals to 3. 1 plus 2 equals to 3, which is true for this step. So we've set n is equals to 1. We've also set n is equal to 2 if is true for any value of n. So let's go to the second step, which is the inductive step. We have the inductive step. In this step, we are to assume that the statement is true for n is equals to k. Then we prove it for n is equals to k plus 1. So let's do it. The question says 1 plus 2 plus 3 plus all the way to n is equals to n open bracket n plus 1 over 2. So inductive step says we assume that n is equals to k. We have to assume that n is equals to k. So if n is equals to k, then the equation becomes 1 plus 2 plus 3 plus all the way to all the way to k, because n is equals to k. So anywhere we see n, we have to substitute it with k. So we have k bracket k plus 1 over 2. Then the next thing we are going to do is that we are going to prove it for n is equals to k plus 1. Let n is equals to k plus 1. So now this equation becomes 1 plus 2 plus 3 plus all the way to k plus k plus 1. So the reason we add k plus 1 is that we set n is equal to k plus 1, which is the next value of n. If n is 5, then k plus 1 will be 6, right? So we say this is equals to k plus 1, because anywhere we see k, we have to substitute it with k plus 1. So we have k plus 1 plus 1 over 2. So if you observe these two equations well, you will notice that everything here is the same thing here, right? We have 1 plus 2 plus 3 plus all the way to k, and that's what we have here. So this is equals to k open bracket k plus 1 over 2. So instead of writing this, I can replace this expression as k open bracket k plus 1 over 2, then plus this k plus 1, which is equals to k plus 1 multiplied by k plus 1 plus 1 is k plus 2 over 2. So what we need to do now is that we have to prove that the left hand side is equals to the right hand side. So how do we go from here? From here, you can take the LCM at the left hand side. You take the LCM, the LCM is 2. Then we have k plus 1 plus 2 multiplied by k plus 1, which is equals to k plus 1 k plus 2 over 2. Simplifying the bracket, we have k squared plus k plus 2k plus 2 over 2 equals to k multiplied by k. We have k squared, because this going to multiply this, the same k you multiply 2, then we have 1 multiplied by k, this same one multiplied by 2. So k times k, we have k squared. K times 2, we have 2k. 1 times k, we have k. Then 1 times 2, we have 2 plus 2 over 2. Then go to add up the like terms. So k squared is alone here. We have k squared plus k plus 2k. We have 3k plus 2 over 2 equals to, we have k squared plus 2k plus k, we have 3k plus 2 over 2. So you can see the left hand side is equals to the right hand side. Then which shows that the statement is true for all values of n. So this is how you prove 1 plus 2, 1 plus 2 plus 3 plus all the way to n equals to n bracket n plus 1 over 2 by mathematical induction. So we are going to take another example. Another example says, prove that 1 squared plus 2 squared plus 3 squared plus all the way to n squared is equals to n bracket n plus 1 2n plus 1 over 6. So the first thing we are going to do is the base case, right? The base case, which is we are going to check if it is true for n is equals to 1. So let's set n is equals to 1 at the right hand side. So we have, if n is equals to 1, we have 1 multiplied by 1 plus 1. Then we have 2 times 1 plus 1 over 6. So we have 1 plus 1 is 2. 2 times 1, we have 2 plus 1, which is 3 over 6. 1 times 2 times 3 over 6 is equals to 1. So 1 squared is 1, and this is also 1. So it is 2 for n is equals to 1. It is 2 for n is equals to 1. Then we can also check for n equals to 2. Don't forget, if you are checking for n is equals to 2, we are going to add up the first two terms. 1 squared plus 2 squared equals to, then you substitute n is equals to 2 at the right hand side. So we have 2 plus 1, then we have 2 multiplied by 2 plus 1 over 6. So this gives 2 times 2 plus 1 is 3. We have 2 times 2 plus 1 is 5 over 6. 2 times 3 is 6. So 6 cancel out 6 here. This gives 5. So 1 squared plus 2 squared. 1 squared is 1 plus 2 squared is 4 equals to 5. So the left hand side is equals to the right hand side. So it is true for n is equals to 2. So the next thing we are going to do is the inductive step. So in this step, we have to set n is equals to k. Set n equals to k. So we have 1 squared plus 2 squared plus 3 squared plus all the way to n squared. So k squared because n is equals to k. K squared is equals to k, open bracket, k plus 1, open bracket, 2k plus 1 over 6. So the next thing we have to do is set n is equals to k plus 1. Or set k equals to k plus 1. So anywhere we see k, we are going to write k plus 1 for it. 3 squared plus all the way to plus k squared plus the next value of it will be k plus 1 all squared, which is equals to k plus 1. We have, if k is k plus 1, then this term will be k plus 1 plus 1. Then we have 2k plus 1 plus 1 over 6. Also, we notice that the expression here is the same thing as the expression over here. Expression over here is k open bracket k plus 1 multiplied by 2k plus 1 over 6. So I'm going to replace all of these with k open bracket k plus 1, 2k plus 1 over 6 plus this k plus 1 all squared equals to k plus 1. K plus 1 plus 1 is k plus 2. Then we have 2 multiplied by k, we have 2k. 2 multiplied by 1, we have 2. Then plus 1, we have 3. So this gives 2k plus 3 over 6. So what we need to do now is that we need to prove that the left hand side is equal to the right hand side. So let's begin by expanding the left hand side. So we have k, then we need to expand this term, right? K multiplied by 2k, then k multiplied by 1, then 1 multiplied by 2k, then 1 multiplied by 1. So k multiplied by 2k, we have 2k squared. K multiplied by 1, we have k. 1 multiplied by 2k, we have plus 2k. 1 multiplied by 1, we have plus 1. Plus, if we take the LCM, this will multiply by 6, right? So we have 6 here. Then we have k plus 1 all squared. K plus 1 all squared is k squared plus 2k plus 1. Then everything over 6 equals to, if we expand k plus 1 and k plus 2, we are going to get k squared plus 3k plus 2. Then we are left with 2k plus 3 over 6. So I have to multiply all through by k. I mean this expression. I'm going to multiply this expression all through by k. So we have 2k cubed plus k squared plus 2k squared plus k plus 6k squared. I'm here now. I'm multiplying 6 by all these terms, right? We have 6k squared plus 12k plus 6 all over 6 is equals to, I'm going to expand this now. So expanding this, we have 2k squared plus 2k cubed, rather. We have 2k cubed because k squared multiplied by 2k, we have 2k cubed plus 3k squared plus 6k squared plus 9k plus 4k plus 6 over 6. So now we need to add up the like terms together. So we have 2k cubed, we have k squared here, we have k squared here, we have k squared here. So k squared plus 2k squared is 3k squared, plus 6k squared, we have 9k squared, plus we have k here, we have k here. So this sum up to 13k plus 6 over 6 is equals to, we have 2k squared here, 2k cubed rather, then we have 3k squared plus 6k squared. This sum up to 9k squared. We have 9k plus 4k, which is 13k plus 6 over 6. So with this, we've proven that the left hand side and the right hand side are equal, because we have 2k cubed plus 9k squared plus 13k plus 6 at the numerator. At the left hand side also we have the same thing at the right hand side. So the statement is true for all values of n. So this is how we go with mathematical induction. Thank you for watching. Do well to subscribe to our channel. Thank you.